As we begin lesson C3, zero and negative exponents, our standard is EE1. You need to be able to use the properties of integer exponents to simplify and know anything to the 0 power is equal to 1. Now the review from the last lessons, I have 2 videos. I also put a couple of video songs on the daily planner that you should watch. And depending on how long this video takes us, I will probably come back to these 2 so you can look at those. But right now, I want to go through the lesson and then we will come back to those. So, what are properties of 0 and negative exponents? 0. Every non-zero number a, remember it's non-zero, raised to the 0 power equals 1. So 6 to the 0 is 1. Negative 24 to the 0 is also going to be 1. For a negative exponent, for every non-zero number a with an integer n, so a to the negative n power is always meaning 1 over a to the n. The other thing I want students to sometimes keep in mind is that if you have 1 over a to the negative n, again to take the reciprocal, 1 over a to the n power. So when I have 4 to the negative 2, I put that as 1 over 4 to the second. That becomes 1/16. When I have negative 3 to the 5th, remembering that this is rewriting it as reciprocal, so it originally was over 1, now 1 over negative 3 to the 5th. Again, if you're going to put this in your calculator, it is very important that you use the parenthesis raised to the 5th power or using that x to the y key on your calculator, but you have to have the parentheses, and in this case it does come out to be a negative 243. Remember, you're multiplying 5 negative numbers together. So as you put that in. So what you're going to be asked to do in your homework is to simplify the expression. Now, the key thing with simplifying is that we really mean no negative exponents. Cannot have any negative exponents, and if you have the same letter in both the numerator and denominator, you need to have it only in one spot. So we start with this problem. We want to think of it as over 1. To simplify it, it's going to be 1 over x to the 9th. And you're done. Please try the next one. Pause the video. As you look at that next one, we want to rewrite it as the reciprocal, 1 over n to the 3rd. Now this is where it gets a little tricky. Keep in mind, 4 is really to the 1st power and b is really to the 1st. So those are kind of already our positive exponents. What's the only one that's negative? The c. So the 4 and the b stay in the numerator, divided by c to the positive 3. I would like you to pause the video now, stop it, pause it, look at the last 2 and try them on your own. And then after you're done pausing it, you'll see me having shown those 2 done. If you notice, as I did this one, the 2 was positive, had a positive exponent, it stayed in the numerator, the a moved to the numerator, became a positive 3. Here, the m stayed exactly where it was. You don't move it if it's positive, only the negative moves to the other spot. And then you could write this answer just this way. It's one too far. Next page, that bottom page in your notes, again, if we're simplifying, I would like you to try these first. Pause the video right now and try them on your own. As you've paused the video, when you turn it back on, I'm going to walk you through the problems. First one, 3 goes down to the 2nd power and we have an n with a 1 in the numerator. That gives us 1 over 9n. That is our solution. If you try the next one going across, the 3 is positive, so is the y. They stay where they are. The 3 and the y stay. What's the only one that needs to move? The x. It was negative 2. It moves to the denominator. It's now positive 2. Now some people usually like to put their variables in alphabetic order. So you might see this answer written this way. Is it the same x squared y as yx squared? Yes. These are exactly the same thing. Again here, you should have seen the 6 was a positive exponent. The a and c were negatives. They have to move. The d is really just 1. So that d is 1. 6 stays where it's at. What's moving? The A has to move to the first power. C has to move, it's now to the positive third. My final answer is 6 over AC to the third. Doesn't matter if you have the 1, it's always understood to be there, so a lot of times they won't write it in. Keeping in mind this last one was all over 1. What's the only thing that was a positive exponent? Was x to the second. X to the second stays. What has to move? 2 to the third moves to the denominator. Z to the seventh moves to the denominator. Our final answer is x to the second over 2 to the third, which you should have had memorized, was 8, and z to the seventh. Again, if you wanted to put a 1 out in front, you could have a 1 here. As you turn to the top of the next page in your notes, it's talking about where do we use these exponential things. It says, well, a population of marine bacteria doubles every hour under a controlled laboratory condition. The number of bacteria can be modeled in the expression where H is the number of hours, so H is our hours, that the scientists measured the population, 1,000 times 2 to the H. And what they're going to ask you to do is to look at this and evaluate each expression for the given values, and what does that represent. So H to the 2, we're going to go back to our equation, and we're going to put in 1,000 times 2 to the second power. We're replacing H with a 2, which just means 1,000 times 4, which gives us 4,000. And we're talking about what? 4,000 bacteria. Gross, huh? And what it means is that this is 2 hours after, my pen's not working right now, after the scientists started the experiment. Started the experiment. So if we're keeping in mind, this was 2 hours after what our population is. Started at 1,000. What does H of 0 mean? Well, first we are asked to solve that. What do we know? Anything to the 0 power equals is 1. So this is really 1,000 times 1, which is 1,000 bacteria. Labels are important. What are we talking about? And when we think of this is when the scientists started the experiment. This is when they started the experiment. Time 0. 0 hours. Well, this last one is asking us, what does it mean when H is -3? Well, again, negative exponents doesn't mean negative, it means reciprocal. So we're going to take 1,000 times 1 over 2 to the third, keeping in mind that that means really 1,000 divided by, because these are being multiplied, 2 to the third is 8. And if you take 1,000 and divide it by 8, we get 125 bacteria. What does that mean? This is how many bacteria, 125 bacteria, 3 hours before the scientists started the experiment. So it's 3 hours before the scientists started the experiment. So you're going to be asked in your homework to explain what they mean too. So make sure you're going to show all this work to how you got the answer for 125. It's now your turn to try it. This is our last page of notes that we are taking a look at for this unit, or for this lesson. It says, okay, the population of insects triples every week. So the number of insects that we are looking at is modeled by this expression, 5,400 times 3 to the W. W is weeks after the population is measured, and they want you to evaluate it for -2, 0, and 1. I want you to use your notes and look at what you just did and try it now for each one of these. So we're going to do it when W equals -2, when W is equal to 0 and when W equals 1. Please pause the video, write out and show your work the 5400 times 3 to the negative 2. Do that for each of these, show your work, and then evaluate what your answer is, and we'll take a look at that in just a minute after you've paused the video. I want you to look at the work that I did, showing the multiplication, showing what you multiplied by to get your answer. Each one of these steps is very important that you put down, and then explaining what it meant. This is now when the experiment had started. This is 2 weeks before the experiment. This is 1 week. Look at all those insects after the experiment started. So it's very important, if you need to pause it again so that everyone has time to write this down. And then we want to, so pause it now, and then we want to now look at what does the value of the expression represent in each situation. So what does the 5400, what does that represent? And what I want you to be thinking about is, this is actually how many insects we started the experiment with. Being, or the number of insects, how many insects being studied in this case. What does the 3 stands for? It is tripling. When they tell you that something triples, we're thinking times 3. And so it's times 3 each week of growth. So the 3 means, if it would have been doubling, we would have had a 2 there. What does the W of negative 2, W equals 0, and W equals 1? Well, we kind of wrote that back here. That is the 2 weeks before. So 2 weeks before we began. This is at times 0. And the last one that we are looking at was 1 week after. So make sure you had time to pause this if you need to copy it down. And as we work on the homework in class, you'll be working on it at home and in class. Then starting next week, we will be doing more of you watching the video and taking your notes at home and working in class. This is what your worksheet looks like. Make sure you simplify, which really means no negatives, exponents. So no negative exponents in any of the problems, and you can't have the same variable in the numerator and denominator. We'll be going through the answers tomorrow in class. Good luck, and if you have questions, make sure you ask.
Peace.